Hello and welcome to everyone on this interesting live session called Increased Part Complexity, where we are going to discuss and share on how to fill the knowledge gap in machining complex part. Meanwhile, if you have any questions during the session, please feed into the chat window. So we will make sure to cover during our session. If we have no time, then we will come back through email messages. So today I would like to introduce the speakers for this session, including me. My name is Janardhan N. I'm Engineering Solutions Manager from the team called Seco Manufacturing Transformation Team. So this is a team which is focusing on the solutions for today's shop floor, right from operation excellency to your shop floor, to engineering support, and also digital solutions to your inventory management. So with me, I have Neil Piper. He's a regional sales manager. He and his team are supporting a lot of strategic key customers in UK. So I welcome him. Hi, Neil. Would you like to say a few words before we get into the discussion?
Yeah, hi, Janardhan. Yeah, just like to say, looking forward to the session, and hopefully we'll get some good interaction with everyone on the call and on the chat. So we're looking forward to it.
Great. Thanks, Neil. And then we have Jason Smith, who is our engineering manager for Innovation Hub here in UK. So he and his team are developing some of the best solutions for complex manufacturing parts. So I welcome Jason. Hi, Jason. Would you like to say a few words before we get into discussion?
Yeah, hi, Janardhan. Obviously, thank you for inviting us to this meeting. Like Neil, just want to reiterate, really hope you find this interesting. And obviously the questions at the end, really look forward to getting those out and answering them. So looking forward to that.
Great. Thanks, Jay. So as I requested to the audience, please feed in as much as questions you can. And if we have time, we'll make sure to answer all those questions, and we'll try to share our knowledge as well. And moving to our next important topic, as a manufacturers, we are spending more and more time in securing our business and also seeking capacity and internal efficiency, especially when we are dealing with complex part. And why? Because the market situation, competition, and most important, your end customers are asking for it. So first, let's try to understand how to identify some of the important issues while you're manufacturing complex part. So to begin with my experience, I would like to share 4 important recurring issues while you're machining complex part. So nobody likes to see smoke while you're machining complex part. So let's get into the issues as quick as possible. So the very first issue that I've identified is not meeting expectation. So focusing on the machining process or the entire manufacturing process, we have number of stages, right from the design department developing a CAD part and then handing over it to the production engineering team, where they would do the programming, defining process and then programming, and also make sure that they post the right codes to machine and finally cut the first part. So during these different stages, we have to make sure that there is something called as the trend knowledge that is required to fill the gap. Sometimes we are adapting the traditional knowledge or methods for the machining complex part. So that could be one of the major reasons for not meeting your expectation. As I mentioned about different stages, if you are not making a connected process, not bringing that agility, a very obvious issue that I've observed is a lack of efficiency. So this is very common issues when we don't see the connectivity between these different stages. And with the today's pandemic situation, everybody is all under a lot of pressure of controlling cost. And also your customers are also looking for the technologies that they would have looked for after 5 years. And I think this is a time everybody got realized that no, we have to adapt this quick technology now. And with these pressures, the cost is becoming one of the main factor for every shop floor. And one of the most common issue for today's shop floor and future shop floor is lack of resources. So how to deal with this resources issue where the people, the most important part to understand, the simple part and the repetitive part has been already taken over by digital solutions. The only left part is the complex part for skilled employees of your shop floor. So where do we find these kind of resources to fill the gap of knowledge that you require for your shop floor when you're dealing with complex part? So to understand these issues and to address these issues, you need an elements. So I quickly go to Neil and ask him a quick question on very important issue called not meeting expectation. Neil, you are meeting customers day in and out. Could you please help our audience and customers on how to identify this issue called not meeting expectation, and especially focusing on complex part when they're dealing with?
Yeah, Janardhan, it's a very good point. I think the landscape is changing. I think that there are limited resources, and we are becoming not just a provider of cutting tools. We're also looking at machine solutions, and we understand the importance of sharing our machining knowledge with our customers. We want them to take advantage of up-to-date cutting tools, but it's also got to be backed by a sound engineering offer that supports their need to produce complex parts and components in a competitive environment. We have access to a number of CAM providers, and these are all integrated with a number of tooling providers in the market. We believe the CAM software, machining strategies, and tooling are the key to producing complex parts. The CAM providers are constantly developing new machining cycles to reduce the persistent issues that can arise when machining these types of components. Tooling is an important part of the offer to our customers. However, we are seeing trends towards the tools being part of a larger offer that includes all our technical buyers, giving the customer what we call the added value, allowing us to deliver winning solutions and help reduce the knowledge gap is very important. We see examples in super alloys of machining strategies that not only influence cycle times and part quality, they also have a positive impact on tool life, which can reduce costs on high value components. And these things are really important.
Mm-hmm. Very interesting point. Thanks, Neil. And I think that summarizes, that you need to have the right technology to drive the complex part. And I think by saying it's very important to understand, as we have this kind of knowledge available in the market, and at the same time when we have this issue called lack of efficiency. So now I straight away move to Jason. So when it comes to a machining complex part, how important to identify this issue, and what is your recommendation to overcome this lack of efficiency, Jay?
Thank you, Janardhan. Obviously, make the process more efficient. What we're really talking about is optimizing your process. There are many ways to do this. And I suppose the main two for us that we drive for is reducing cycle times and reducing the number of times the operator has to intervene inside the operation. So by doing this, that can lead to a much more robust and stable operations and conditions, which leads to better parts. And if we reduce the cycle times, it also creates more capacity. And the more capacity you have is the more space you have for future developments as well, to improve those tool paths and those setups even further. But it also gives you the capacity to take on more work. So you're making your business more revenue. Mm-hmm. And we also, part of this whole process of optimizing the process is by working with our technical partners. So we're using all our knowledge together to get the biggest gains.
Mm-hmm. Very interesting. Thanks, Jay. But I think, again, coming back to you, because when I see these two words, and when I'm hearing from a lot of customers and my friends, they always get confused with optimization and controlling cost. Are these two are kind of same thing, or should we have something exclusive called cost analysis when it comes to complex part? What is your approach on controlling cost for complex machining?
Well, to me, with regards to my perspective and the business, cost reduction and cycle time, most customers want both. However, there'll always be a kind of a leaning towards one of those sectors. Obviously, that goes without saying. You don't want to drop the high quality standards, whatever we do. Mm-hmm. However, you can actually make a feature very quickly and without inducing the cost as well. And one of these known types of machining techniques nowadays is dynamic milling. and that's where we're using the full length of the tool to actually machine out pockets and areas that are hard to reach at a much higher feed rate, but obviously making full utilization of the tool as well. So yeah.
Good, good. Very interesting, because this plays a very important role in today's shop floor, that how to really balance this, focusing on what kind of activity, whether it is pure optimization or optimization included cost control as well. Yeah. Thank you, Jason. Thank you for helping us with your information. And going forward with addressing one of the important issue for on all of these 4 recurring issues, that is lack of resources. I'll go to Neil and ask you this question. What is your recommendation to our audience and customers, how they can find the right resources with the today's situation? What are the different ways? Can you please help us with your ideas?
Yeah, it's a good point, Nard, and I think in the market nowadays, with the customers that we deal with, they have limited resources. They're very busy. They're working on projects. And, they are relying more on, tooling providers like us to develop their processes. This helps them reduce their machining issues. We're collaborating on projects, we're providing robust machining strategies, and we are lowering the risk of their persistent manufacturing issues. I think the customer looks at us as an extension of their team, which, leads to opportunities for both parties. I think that's a very important point. We are an extension, we collaborate, and we are trying to work together to reduce these kind of issues that they see with these complex parts. I mean, the key is to have the experience of the customer aligned with a tooling provider and CAM software experts. This knowledge makes the machining process more robust. Mm-hmm. It gives the customer confidence that they can machine these parts successfully without the risk of high machining, tooling, and quality costs. The lack of resource that we see today, it's very important we have that collaboration and that partnership between all parties to iron out all these issues right at the beginning of the manufacturing process.
So absolutely. I mean, this is very interesting. When you said about you as a technical partner extending and making customer feel like your extended production team for them in filling the knowledge gap. So bringing this collaborative way of working is very, very important for today's shop floor, so that they can find the right source for the knowledge in driving the complex part. So I think if I want to summarize all these 4 points and try to remember in 3 simple words, that considering the key elements what Jason and Neil told, we have to be very agile, quick enough to identify these knowledge which are available in the market from the source, and also adapt it as quick as possible. You have to be flexible to adapt these kind of solutions which are trending. And most important, not by just identifying, you have to make sure that you have to authenticate it actually from the right resources. As Neil mentioned, you need to have the right technical partners to validate for the knowledge that you want to apply for your shop floor when you're dealing with complex part. I think moving to a next interesting point for everybody is to have more good control on the shop floor, because we see there are very important 3 stages in your shop floor when you're dealing with complex part. One is the design department developing the CAD part. Sometimes they usually not considering where it would be manufactured. And the second stage is very important stage is the preparation for the actual manufacturing activities. And the final is to see the first part when it cuts and you see that wonderful part coming out of the machine. So here, my question to Jason, what is your experience as an engineering manager and as a team member of your team, Innovation Hub? What are your recommendations for the audience? What are the areas they have to be prepared and considered before they start this activity? Could you please help us with your additions?
Absolutely. I mean, obviously, you've just mentioned it there. For me, the first point is design for manufacture. You sometimes see a lot of parts or features designed where the feature is very difficult or almost impossible to machine, and that could be alleviated right at the start by joining the design team up with the manufacturing team. By getting that, you kind of resolve those issues far in advance of starting this process. But once you do have that component or that feature, you've got to know all your inputs. You've got to control all those valuable inputs to know that your output's going to be correct. So things like your machine tool, we need to know the exact setup of your machine tool. Is it a 3, a 4, a 5 axis? How powerful is the spindle? How quick can the spindle run at? We need to know the material. You know, without the material, we can't select the right tools or the right cut data. Work holding, another massive part in this. You know, is there existing work holding? Because the work holding, along with the machine tool, will tell us how we're going to approach this project. We can't exactly, you know, if the work holding is holding it a certain way, we might not better hit a face that we want to hit at the certain time we want to hit it. And that goes against as well that if you wanted us to design the work holding, we need to design that with how the machine's going to react with that. So if it is a 4-axis machine, how are we going to design that work holding around that so that we can hit those features? We need to know the cam system, you know, specifics around the cam system, what level you're at with it, what certain toolpaths you had. There's no point in us programming something if you can't actually run it at your place. With regards to actually proving off any code, we need to know how you're going to prove that code. Many companies or many customers, they do that in many different ways. Some do it just by dry running. Others will use offline simulation software. And if it's offline simulation software, we need to have that design of that tool or that machine tool along with the control as well, so that we can do that for you. Along with all this, obviously, once we've got all that data and we've started producing, we need to have those regular update meetings so that we're all on the same page. We know exactly what's happening and we know the next steps that where the project flows. And once we're at the point of machining and we're doing our first prove out, it's very important that we actually stood there with the customer or with you to make sure that we can hear, feel, sense what's going on in that process, in that part where the tool's hitting, so that we can make small adjustments, minor adjustments at the time to best suit the actual setup that you've got in your factory. And then only when all that is done and we've completed all that can we have the best possible chance of having the first part off right first time. So.
It's very interesting when you said about, you know, hear, listen, and feel about what's happening in the process of machining. I think that's where the experience and the skills and knowledge comes into your place. So people like you, you know, who have vast experience. So I think these are the, you know, understanding that we have to give to today's shop floor, that it's not just, you know, okay to apply the traditional methods that you know from different way, but you have to make sure to apply the right knowledge.
Absolutely.
So just to summarize, thank you, Jay, for that wonderful, you know, the stages and control points that you've recommended for the audience. And just moving, you know, to the next stage, I just want to summarize to the audience. And before summarizing, I would also again request, if you have any questions, please feed into the chat, and we'll make sure to answer by end of the session. So going quickly on the summarizing, just on the recurring issues and the key elements that we spoke today. So make sure that you may have these kind of hidden issues in your shop floor while you're manufacturing complex part. So make sure you to find it out and get the right source to address these issues, and by getting these right elements from the right technical partners. And by saying it is very important, one of my favorite quote, you know, that I always remember, because everywhere we hear about knowledge, a lot of people are organizing webinars and sessions, everybody talks about it. But at the end of the day, it is you who have to apply to your shop floor while machining complex part on the knowledge that we are talking about. And if you need more support on this kind of knowledge, please get into touch with one of us in the session. And if you need more information, log on to our, you know, information center, and then you can get more information about, you know, the knowledge that we are talking about. So now moving to an important session, question and answers. So I'll straight away pick, you know, quick questions from the chat, and you know, try to answer those questions. So the very first question that I've got is, what are the specific checkpoints you recommend before we define machining process for super alloy material? So I would like to park this question to Jay. Could you please answer this question?
Yeah, certainly. Well, obviously, super alloys, as the word goes, they're very difficult to machine. They can work hard, and so the main ones for me and my team would be that we need to know the exact material specs so that we can get the exact correct cutting data. We even percentage down cutting data based on materials, so we can kind of factor that into the approach. We also need to know the machine type as well, so regards to the spindle back end, how much power the spindle has, what speeds we can hit. That then obviously governs how we're going to approach the part. We may look at saying, rather than using using like carbide and trying to feed it off very, very quickly, because we might not have necessarily the right connections on the machine, we turn more to maybe a high feed approach and put the forces back up through the spindle, depending on the age of the machine. So those two for me are the main two factors I would look at with regards to super alloy machining.
Perfect. I hope the audience have got their answer for this, and thanks, Dave, for answering that. And quick next question for you, because it's very much technical on the engineering side. So I'm going to ask you this question. Can you talk about NOD mag insert called CNMG 1906124,000 and how it can help complex manufacturing?
If I'm honest, it's an insert that I'm not very familiar with within the Seco range, but I will take that question back to our turning product manager. I'm unsure if Neil might know of it a little bit more.
Yeah, I'm assuming, yeah, it's a good point, Jason. I'm assuming, guys, that the 4,000 maybe would be the TM 4000 grade. So, it's obviously a grade that we now have superseded with the new TM grades. And these grades are very, very important on machining super alloys and stainless steels. And, we are seeing elevated data, which can help to machine these complex parts, because it creates a machining condition that's very stable, which is very important. Just following on from what you said, Jason, regarding super alloys, the most important factor for myself when I'm looking at these projects is we want a stable process with stable tool life. It's very important, because we all know that when these tools wear, the wear patterns are not gradual, they're exponential. Yeah. And that can create, major issues. So, a robust, tool life library is very, very important for us when we're working on these projects.
Absolutely. That's a very good suggestion. I think that was a question from the audience, and I don't remember the name, sorry for that. But I am going to quickly jump to the next question on this is, again, I don't see the audience name here, but I have the question here. Unlike engineering simulation, can run online simulation based on data in real time received from sensors connected to the machine, so that operator present on the shop floor may identify why a part is malfunctioning? Yeah. Jake, can you able to answer this? Have you do you have experience that customers are playing around with the sensors? Because I have seen with my experience, I can quickly say a few points. Yes, there are possibilities, when we run the test part, especially before we really work on the real part, these sensors would play an important role in identifying the vibrations, and so that we can control the forces on the spindle or on the tool that we apply, the parameters we apply. So we can play around with those, and we can try to control any malfunctioning which could damage the spindle or the workpiece. So, Jay, do you want to add anything on this question?
I think you're right, kind of thing. There's two ways to this. When we talk about offline simulation, we're more looking for collisions, making sure the code is correct before it hits the machine. With regards to the online simulation, it's more around, like you said, the forces that are being applied. So we're always monitoring the spindle or the X-axis ball screw or something like that. That kind of feedback has to, like I said, that could be vibrations happening in there. And there are functions moving forward where that feedback loop is going through to actually change the feed or the speed through the process at the time, through the machining process. And that's really innovative at the moment, and kind of inspiring as well, to say that you can actually change feeds as you're running a part to make sure you get a better component at the end.
Yeah, I think that's a great point, Jason. And another point from myself is, the collaboration with the machine tool builder. You know, a lot of these machine tools, we all know the most expensive parts on these machine tools are the spindle. And, you know, if we have robust data and tool life calculations that we can feed to the machine tool builders, they can set the parameters on the spindle for loads. You know, it's much more important for the tool to be stopped before a collision or before the insert wears out, because, you know, A, you're not damaging the tool, B, you're not damaging the component, and C, you're not damaging the spindle of the machine. So there's some great collaboration there. We work very closely with the machine tool builders on projects when, you know, especially when machining super alloys.
Yep.
Absolutely. Good. Thanks, Neil and Jay. I think I'm reading one of the comments here. I don't see as a question, but still I would like to read that comment. Saying need more knowledge exchange from tool manufacturers, as the tool manufacturers can be the major resource to share the tool and program strategy. There need to be also more practical short case study, I think, videos which can shared to the small and big shops. I think, to be honest, I think a lot of our tool manufacturers, especially Seco, has been in this field for 8 decades. There's a lot of knowledge that we've been keep on pushing to the market through our social media and digital marketing way. I think there are a lot of sources. If I find out the source of person who's asking Govind, I would definitely send you some of the links where you can find such interesting case study that we as a tooling manufacturers that you know, sharing with our audience and customers. Thank you for that point.
I think Janoran, just to add to that, I think the question is also looking at, you know, we're developing tools as a tooling provider, you know, daily, yearly, and you know, our customers, they need to keep up with the technology changes. So it's very important for us to be able to feed that information to them, and also to our partners and CAM providers. You know, you can have the best tool in the world, but if we don't know, you know, basically how to use it, and we haven't had the right platforms, that's really important for the customer.
Yeah.
Very valid point. I think that gives me another thought to share with the audience is, most of the time we just conclude by saying tooling suppliers, but again, hence we are developing those tools. You know, it is more than tool that we can help and support customers. So it's a very right way of understanding where the knowledge is coming from. So really, thanks. It was really interesting comment. So moving to the next question. Again, I think it is a comeback question to Jay, I believe. So saying, thanks for answering the question on superalloy material machining. Could you share technology trends on machining composite material?
Okay. Obviously, the composites market is fastly growing. We know it's going to be bigger and bigger as the days goes on. We do have a big development on composite cutters. We did do a demonstration last year at our ITI event as well, showcasing PCD on composites, as well as our latest carbide cutters. And we are actually now looking at the next phase is how we can introduce a certain type of MQL or minimum quantity lubricants into machining composites that can increase tool life even further. So, you know, obviously we're always developing, but that's the next stage. It's very, very early at this moment, but we are seeing some positives in that area.
Very interesting.
And we, to put off, we do have a CFRP area expert within our business. So if that person wants to get in contact, we can certainly put in contact with that person for a more in-depth, detailed look at that if they feel like.
Absolutely. So very, very good answer to that question, Jay. Thank you for that. It's just because we're running out of time, so I would quickly, you know, I think there are a few more questions in the chat. I can come back with email message replying to you guys, but with less time, I'm quickly requesting to the audience, you know, a big thank you to all of you, and also a request now, a survey for now, which would take just 2 minutes. And feel free to comment about this session. And if you would like to listen more on any specific topic related to our machining complex part, please let us know, and we'll make sure that we'll organize such events in future. And also very interesting, in next in a couple of days, 29th of June, we have one more interesting live session where we will be discussing on redefining performance of complex manufacturing machining shops. Please attend this and also do share with your friends and colleagues. Let everyone get this knowledge of what we're talking about, complex manufacturing world. So this is the right time to share the knowledge. So by saying, I would like to wish everyone thank you so much and stay safe. Goodbye.